In this video, we'll start doing method of substitution in integration. We'll first see when to apply this method because I think that's the most critical part to knowing when to apply this method. Then we'll see how to apply that method. And then we'll go on to your exercise 7.2. We'll solve the full exercise in detail with all crystal clear explanations. This is the only video on YouTube where you'll get such a detailed explanation of this exercise. Let's get started. All right, now let's start with when to do this method of substitution in integration. Method of substitution is done when your function contains a composite function and derivative of that composite function is present. Let's see with this with the help of an example. Let's say if I have a function, let's say square root of x. Now square root of x is a simple function, but the moment I replace that x with some other function, let's say I replace that x with sine x, then this becomes a composite function. Okay, root x was a simple function. But the moment I replace x with sine x and I get the function square root of sine x, that is a composite function. Okay. So whenever your function contains a composite function and the derivative of that composite function is present. So for example, the derivative of sine x is cos x. So let's say if you had integration of root sine x times cos x dx. In this situation, we'll do method of substitution. Okay. So whenever your function is composite and the derivative of that function is present, or it can be arranged. If it's not present, here it is present directly. But there will be situations when it won't directly be present, but you'll have to make some tweaks and simplification to bring that derivative. Okay. In all such situation, you will do method of substitution. Okay. Now let's see how to represent this mathematically. Now this can be represented mathematically as, let's say, if you want to integrate fu. So you don't want to integrate fx. You want to integrate fu with respect to x, and the derivative of that function is present. So if you want to integrate fu where the derivative of that u is present, in such a situation, we do method of substitution. I call it MOS, method of substitution. All right, now let's see how to do that method. Now, in order to do method of substitution, it's very simple. Whatever the composite part, in this case, the composite part was sine x. Okay, instead of x, you replaced it with sine x, and there was a derivative of sine x present. So in this case, I would have put sine x is equal to t. We would have to substitute sine x is equal to t. In general, in here, if you have a function of u, you would replace u is equal to t. That's what you would do as your first step in method of substitution. You would do u is equal to t, and then you would proceed and simplify. Proceed and simplify. We'll see with the help of an example on how to simplify this and how to integrate later on. But that's how you do. You basically put u is equal to t, and then you proceed and simplify. Now let's get started with exercise 7.2, question number 1. It says 2x over 1 plus x squared. Now, if you notice this, derivative of x square is 2x. So the derivative of x square is present. Also note that we cannot directly integrate this. We cannot directly simplify this. We cannot directly split it or do any kind of algebraic simplification to simplify this. So we check whether if there is a function whose derivative is present. Here we see that the x square, the derivative of x square is 2x. Okay, if derivative of x square is 2x, what you can do is you can say put x square equal to t. You put that x square equal to t. Then next, what you do, you differentiate both sides with respect to x. So differentiate with respect to x on both the sides. Okay, that's what is the simplification part of it after this. So the derivative of x square with respect to x is 2x. Derivative of t with respect to x is dt by dx. Okay. Now, if you see the 2x dx, the numerator, 2x dx. So we can multiply this dx here. So we get, therefore, 2x dx is equal to dt. So 2x dx is equal to dt. Okay. Now what you can do is convert this entire function in terms of t. Convert that entire function in terms of t. So we have integration. So this numerator 2x dx, 2x dx is dt over 1 plus 1 plus x square is t. So 1 plus t. In order to integrate this, remember that integration of 1 over x dx is nothing but log mod x. We also know from our previous video that instead of x, if there was ax plus b or linear term in x, if instead of x, there is a linear term in x, we know that we can still apply the same formula of integration. So if integration of 1 over x is log x, integration of 1 over ax plus b is also log mod ax plus b, but you just have to add an extra term. You just have to divide with an extra term, which is coefficient of x, which is a. Okay, so that we know from the logic of integration that we saw in the previous video. So in order to now integrate this, this is just like 1 over ax plus b. Okay, so the integration of this is log mod ax plus b, which is 1 plus t. You divide by the coefficient of x. The coefficient of x here is a. The coefficient of t here is 1. So you just divide by 1 plus c. So basically the integration result that you get is log mod 1 plus t plus c. That's the result of integration that you get. Remember that after you are done integrating here, you have to convert your answer in terms of x. So that t, we know that t is x square. So you just replace that t with x square. So you get log of mod of 1 plus x squared plus c, which is then your final result. All right, now let's move to question number 2. We have log x over x the whole squared. Now notice that here instead of x square, this is like log x squared. So this is a composite function present, and also the derivative of log x, which is 1 over x present here. Okay, so in such a case, if derivative of log x is 1 over x is present here, we can just say put, we can say put log x is equal to t. Therefore, if we put log x is equal to t, then just differentiate with respect to x on both the sides. Differentiate with respect to x. So we get derivative of log x with respect to x is 1 over x. Derivative of t with respect to x is dt over dx. Now let's convert entire function in terms of t. So we see that there is dx over x present here. So this dx can be taken on this side. So you get dx over x is equal to dt. Okay, so you get dx over x as dt, and we already know log x is nothing but t. So your integral will become t square. So since it's log x square, you get t square, and the dx over x is nothing but dt. So you get t square dt. Now it's a very simple function now to integrate. The integration of t square is t cube over 3 plus c. Also remember in the end to replace that t in terms of x. So we know t was log x. So you get log x the whole cube divided by 3 plus c, which is your final result of integration. Now let's look at question number 3, 1 over x plus x log x. Okay, to simplify this, let's say we just take x common from the denominator. So we have integral of 1 over, take x common, so you have 1 plus log x. Okay, now if you notice, the derivative of log x is again 1 over x, which is present here. Okay, so you can actually put log x is equal to t. Okay, you can also put entire this 1 plus log x equal to t. Either way works. You can either put log x equal to t or 1 plus log x equal to t, because the derivative of 1 is anyway 0. Okay, so let's actually put 1 plus log x as t. So you can actually put this 1 plus log x as t. So put 1 plus log x as t. Okay, you can also put just log x as t, but I just include that one to make it simpler because the derivative of one is anyway zero. Okay, now you just differentiate on both the sides. Differentiate with respect to x. So the derivative of 1 is 0. Derivative of log x is 1 over x. Derivative of t with respect to x is dt by dx. Okay, therefore you get, so 0 plus 1 over x is 1 over x equals dt by dx. Okay, therefore let's convert entire function in terms of t. If you see here, dx divided by this x, you can take the dx over here to get dx divide by x. So you get dx divide by x equals dt. So if you take the dx in the numerator, you get dx by x is dt. Okay. Now that you have that, you can convert entire function in terms of t to get integral of so okay, this here 1 plus log x is t. So this denominator is t, 1 plus log x. Dx over x is nothing but dt. So in the numerator you get dt. So basically you are left with integral of dt over t. Now this is just like 1 over t. The integral of 1 over x or 1 over t is log mod t plus c. Okay. Now you can convert this back into x. We know t is 1 plus log x. So this will be log mod 1 plus log x plus c, which is your final result of integral. Okay. Let's look at question number 4. It is sin x into sin cos x. If you notice, this is a composite function again. So we'll have to apply method of substitution again. If you also notice that composite part, the derivative of cos x is minus sin x. That minus can be arranged, but remember that derivative of cos x is minus sin x. So that sin x is present here. So which is why you can say put that cos x equal to t, because the derivative of cos x is minus sin x, which is present here. Okay, if you put cos x is equal to t, you get differentiate with respect to x. So therefore, differentiate with respect to x. Therefore, you get derivative of cos x is minus sin x equal to derivative of t with respect to x is dt by dx. Now let's convert the entire function in terms of t. Okay. We can see here that this is sine. So we put cos x equals to t. So this is my t. Okay. Also notice this sin x and dx. This sin x times dx. So this dx can be taken on this side to get sin x times dx, and just take this negative on the other side. So you get minus dt. So sin x times dx is minus dt. So that's the result. So sin x times dx is minus dt. So you can now convert the entire function in terms of t to get, therefore, you have integral of you have sin x dx is minus dt. Sine, you put cos x equal to t, so this is nothing but sine t dx. Oh, sorry, you already have dt. You can take this negative out of the integral to get minus integral sine t dt. Now this is minus integral of sine t is minus cos t. Integral of sine t is minus cos t plus the constant of integral c. Now that negative negative will become positive, and you can replace, you can convert this again in terms of x. So t was cos x. So this will become cos of, this negative negative is positive, t is cos x. So you get cos of cos x plus c. Replace that t with cos x, which is your final result of this integral. All right, now let's integrate sine ax plus b times cos ax plus b. There are two methods with which you can integrate. You can directly actually apply trigonometric formula here to integrate this, or you can do method of substitution. Either way works. Let's do method of substitution since we are doing that method of substitution here. We know that derivative of sine x is nothing but cos x is present here. Okay. Also, the derivative of cos x is minus sine x. That is also present. So you can either substitute this sine ax plus b as t, or you can substitute cos ax plus b as t. Doesn't matter here. Okay. So sine. Let's put sine ax plus b equals to t. Now, if you put sine ax plus b equal to t, now let's differentiate with respect to x on both the sides. Differentiate with respect to x. Remember that you'll have to use chain rule here to differentiate, okay? So the derivative of sine ax plus b is cos ax plus b times derivative of ax plus b. So the derivative of ax is a plus the derivative of b is 0. You'll have to use chain rule here to differentiate is equal to t. Therefore, this a plus 0 is a, so this becomes a times cos ax plus b is oops, sorry, I should write here the derivative of t is dt by dx. So this is equal to dt by dx. Okay. So notice here, since you put this as t, this is your t, you have here cos ax plus b times dx. Here also cos ax plus b times dx. So if you want to convert this entire function now in terms of t, you can write that cos ax plus b times dx, cos ax plus b times dx as cos ax plus b times dx equals, you can just take that a in the denominator here is equal to dt over a. Okay, so that's the value you found out. So you have cos ax plus b times dx is dt by dA. You know this is t. So your integral will become, therefore your integral will become t times dt over a. Okay, so t times dt over a. Now you can take that a out of the integral. So you have 1 over a integral of t dt, which is equal to 1 over a integral of t is nothing but t square divided by 2 plus c. Okay, integral of that t is t square divided by 2. Now remember to replace that t with whatever you had substituted initially. Okay, so final answer should be in terms of x. So we know t is sine ax plus b. So this will become 1 over a sine. So this is sine ax plus b. So sine ax plus b squared divided by 2 plus c. That's your final result for integration. All right, now let's integrate question number 6, square root of ax plus b dx. Now, in order to integrate this, you can use method of substitution because it's a composite function. Ax plus b is a composite part, but you don't really have to because it's just a linear function, right? So this can be just written as ax plus b to the power 1 by 2 dx. Now we already know that integral of x to the power half dx is x to the power 3 by 2 over 3 by 2, right? We know this already. But if instead of x there is a linear term, if instead of x there is a linear term, ax plus b, the same formula can still be applied. So ax plus b raised to 3 by 2 over 3 by 2. You just have to multiply with the coefficient of x. The coefficient of x here is a. Okay, so this is actually the integration of this really. Okay, but if we let's since this is the exercise for method of substitution, let's do method of substitution, right? So if we do method of substitution and say put ax plus b is equal to t, put that ax plus b is equal to t. Now differentiate both sides with respect to x. Differentiate with respect to x. So the derivative of ax is a, derivative of b is 0, derivative of t is dt by dx. Therefore, therefore, remember that here now we have to convert this entire function in terms of t. So this is t, ax plus b, this is t, and we need to replace dx with dt in some way. Okay, so that let's find that value of dx. So here dx is equal to, let's take the dx in the numerator and that a in the denominator is dt over a. Okay, so we find that value of dx. So dx, you take it in the numerator, this a plus 0 is a, take that a in the denominator. So dx is dt over. Now let's convert this entire function in terms of t. So we get integral of ax plus b is t. So that's t to the power half. And the integral of, or sorry, the dx is dt over a. So dt over a. So now this is equal to, that a is a constant can be taken out of integration, 1 over a integral of t to the power half dt. So now this is 1 over a. Integral of t to the power half is t to the power half plus 1, which is 3 by 2 over 3 by 2 plus c. Okay. Now you can simplify this further. Take that 2, which is in denominator's denominator in the numerator. So that 2 will come in the numerator. So you get 2 over a times 3 is 3a. And here t, instead of t, you can actually again write ax plus b. So you can write ax plus b raised to 3 by 2 plus c. And that is your final result of integration. I hope that makes sense. All right, now let's integrate x times square root of x plus 2, question number 7. Now, in order to do this, if you see, this is the composite part. Square root of, instead of square root of x, you have square root of x plus 2. So let's put square root of x plus 2, or sorry, let's put x plus 2 equal to t. Now, the derivative of x plus 2 is nothing but 1, and 1 is always present. Okay, so you can easily put x plus 2 as t. Now differentiate both sides with respect to x. Differentiate with respect to x. So you get the derivative of x is 1, derivative of 2 is 0, derivative of t with respect to x is dt by dx. So in this case, 1 plus 0 is 1. So you get 1 is equal to dt by dx. Therefore, you get dt is equal to dx in this case. Dt is just equal to dx. Now let's convert this entire function in terms of t. We know that this dx is nothing but dt. So you can just replace that with t. This x plus 2. X plus 2 is nothing but t here. So this is t. Now what about this x? How to convert that x in terms of t? So in order to convert that x in terms of t, if you notice here, x plus 2 is equal to t. So which implies that x is t minus 2. X is t minus 2. Because we need that x, we need to convert it to t. So we write x is equal to t minus 2. Now let's convert entire function in terms of x. So we get integral of, instead of this x, we can just write t minus 2. T minus 2. Instead of square root of x plus 2, we can just write square root of t. And instead of dx, we can just write dt. Okay. Now it's very simple now to integrate this. We can just multiply square root of t inside. So we get integral of t times square root of t minus 2 times square root of t dt. Okay. Now we can simplify this further by law of indices. We know t to the power 1 and this is t to the power half. So the if the base is same, the power gets added. So t to the power 1 and t to the power half. This will become t to the power 3 by 2 minus 2 and square root of t is t to the power half. And you get dt. Now, in order to integrate this, the integration of t to the power 3 by 2 is t to the power 5 by 2 over 5 by 2 minus minus 2. The integration of t to the power half is t to the power 3 by 2 over 3 by 2 plus constant of integration, which is c. Okay. Now you can just say, you can just replace that t. If you now we need to convert it again in terms of x. So we had put x plus 2 is equal to t. So now what you can do is you can just replace that t again with x plus 2. So x plus 2 raised to 5 by 2 divide by 5 by 2 minus 2 x plus 2 raised to 3 by 2 divide by 3 by 2 plus c. You can just simplify this further. This 2 can be taken in the numerator. So 2 times x plus 2 raised to 5 by 2 over 5 minus this 2 can be taken here. So it will become 4 by 3. This 2 and 2 will become 4, and then there is this 3 x plus 2 raised to 3 by 2 plus the constant of integration c, which is your final result.